All right, so this is section 4.3, and we're going to talk about right triangle trig. Right triangles are something that you have dealt with probably since like a fifth, sixth, seventh grade math course, but we want to kind of dive into it a little bit deeper. But first, let's just again kind of recap what a right triangle is. All right, so a right triangle is a triangle that has a 90-degree angle or a right angle. Okay. And this is all right triangles have a 90 degree. And something that you probably remember is the word hypotenuse. All right. So the hypotenuse is the side that is directly across from the 90 degree. All right. And what we want to do with this is take it a little bit further and say, well, if we have an angle here, let's call it theta, then there's also an opposite side and an adjacent side. Okay? And all triangles, all right triangles, all of these numbers are related directly. They can't be random because they have to satisfy what's called the Pythagorean theorem. And most everybody usually has a good understanding of what the Pythagorean theorem is. And if you remember from maybe your high school geometry class or middle school, the Pythagorean theorem says that a squared plus b squared is equal to c squared. Okay. Well, for this course, instead of saying a, b's, and c's, we might want to look at that and say, well, the opposite squared plus the not the hypotenuse, plus the adjacent squared is equal to the hypotenuse squared. Okay, and we will be using the Pythagorean theorem to solve some problems, but the first thing that I want to look at now is from a trig standpoint, and trig is all based off of right triangles anyway. So there are some relationships with these that we need to know. All right, so we have the sine. So the sine of this angle, theta, is equal to the opposite side divided by the hypotenuse. So opposite over hypotenuse. Okay, and you may remember this, something like SOHCAHTOA is a common acronym to remember these. But we have the cosine of theta that is equal to the adjacent side over the hypotenuse. Okay. And then we have the tangent of theta is equal to the opposite side over the adjacent side. Okay. So these are the three that you are probably most common with on their relationships. But I do want to go ahead and take it further because we do have some more trig relations that we can add in. So let's look at the cotangent of theta. The cotangent is of theta is the adjacent side over the opposite. So it is just the reciprocal of the tangent. Okay. And then we have the secant of theta is equal to the hypotenuse over the adjacent side. All right. And then cosecant of theta is equal to the hypotenuse over the opposite side. All right, so as you can see, these are all related because there's only so many combinations that we can have. So as an example, cosecant is just the reciprocal of sine, and then secant is the reciprocal of cosine, and so on. But just have these written down on hand for you. They are in the textbook in section 4.3, so if you do need the list, you can reference that pretty easily. Okay. And so the kinds of questions that we want to be able to answer with this are, let's say that we're given a right triangle, and a very common right triangle is a 3-4 triangle. So let's say we have 3 and 4 here, and we're going to look at this angle theta. Okay. Well, the first thing that we need to find is to be able to answer these questions is because we want to be able to identify, what's the sine of theta? What's the cosine of theta? We want to be able to tell what's the tangent of theta, and so on. So we'll do all 6 that we just covered. But the first thing we need to be able to find is the hypotenuse, right? We don't know what that is. Okay, so we can find that using the Pythagorean theorem. So the Pythagorean theorem, again, is a squared plus b squared equals c squared, which is to say, okay, I have 3 squared plus 4 squared is equal to the hypotenuse squared. Well, that's 9 plus 16. The hypotenuse is equal to the hypotenuse squared, which is 25. Okay. Take the square root of both sides, and I find that my hypotenuse is equal to 5, which is a very common right triangle to have a 3, 4, 5 right triangle. Okay, and so now we just want to be able to answer these trig relationships based on this triangle. All right, so the sine of theta, I know according to my list, is opposite over hypotenuse. My opposite side is 4. My hypotenuse is 5, so I have 4 over 5. Cosine of theta is adjacent over hypotenuse. My adjacent is 3. My hypotenuse is 5, so I have 3 over 5. Okay. My tangent is my opposite, 4, over my adjacent side, 3. Just to confirm, opposite over adjacent, which is 4 over 3. Okay. My cotangent side, my cotangent, again, is adjacent over hypotenuse. So my adjacent side is 3, my hypotenuse is 5. Excuse me, not my hypotenuse. Adjacent over my opposite. My apologies. Adjacent over opposite. Adjacent is 3, opposite is 4, because it's the reciprocal of tangent. Okay. And then we have secant theta. The secant of the angle is the hypotenuse over the adjacent. The hypotenuse is 5, the adjacent is 3, so I have 5 over 3. And then I have cosecant of theta. Cosecant of theta is hypotenuse over opposite, which is 5 over 4. Okay. So whatever this angle is down here, doesn't really matter, but the cosecant of that angle would be 5 over 4, and so on, okay? So that's how we can use a right triangle trig to be able to find theta. We can also be able to find missing sides if we know the angle, etc. Okay. Now here are some common trig identities, and I will post a PDF of the trig identities under or on the course page. But here are some common trig identities that you're going to see pop up here during this video. So let's go ahead and write those down. I think I spelled identities correctly. All right, so the sine of theta is equal to 1 over the cosecant of theta. And I do not expect you to remember these. Just write off. As you start referencing them more and more, you'll know them. But, it's not. I'm not going to quiz you on, your ability to memorize these. Okay, and then cosine of theta is 1 over the secant of theta. The tangent of theta is 1 over the cotangent of theta. Cotangent of theta then is 1 over the tangent of theta. Secant is 1 over cosine, and cosecant is 1 over sine. So you can see that sine, cosine, secant, cosecant are related, and then tangent and cotangent are kind of on the island of themselves. All right. Here's another couple identities. Again, I'll have this in a list, but the tangent of an angle is equal to the sine of the angle divided by the cosine of the angle. Right? Sine kind of corresponds with opposite. Cosine corresponds with adjacent, so there you have opposite over adjacent. Then the cotangent of an angle is just the reciprocal, the cosine over the sine of the angle. Okay, and I have a few more that I'll include on the next page here, but just give you a moment to get these written down. All right, and so now the last few that I want to mention is the sine squared plus cosine squared. So this is kind of familiar and looking like the Pythagorean theorem. So sine squared plus cosine squared is 1, and that's a common one that we will get to use quite a bit. Then the 1 plus the tangent squared is equal to the secant squared theta. And then 1 plus cotangent squared theta is equal to cosecant squared theta. Okay. All right, so let's do an example problem with this. Let's do something like, let's take this. Let's take something that we are simplifying. Like, let's say we have the tangent of theta plus the cotangent of theta, all divided by tangent of theta. Okay, and our goal, this is actually similar to one of your homework problems. Our goal is just to simplify this as far as we possibly can. Okay, and the homework problem does give you the first few steps. But I'll step you through those also. So the first thing I can notice is that I can break this addition up and say, well, that's the tangent of theta over tangent of theta plus cotangent of theta divided by tangent of theta. Okay. Now, just like in regular, everyday math and arithmetic, it holds true under trig. So tangent of theta divided by tangent of theta is just 1. Okay. All right. And then one of the identities that I just gave you on the previous page was that the tangent of theta is equal to 1 over the cotangent. Okay. So I could switch either one of these that I wanted to. I'm going to choose to deal with cotangents. So that is really 1 over the tangent of theta. No, excuse me. Sorry. Tangent is 1 over the cotangent of theta. Okay. Something that you may have remembered, anytime that you're dividing by a fraction, that's the same thing as saying to multiply by the reciprocal. So really this is cotangent of theta times cotangent of theta, which is equal to just 1 plus the cotangent squared of theta. Okay. Well, now looking at my other trig identities here, I can see that 1 plus the cotangent squared of theta is cosecant squared theta. Okay. So that's just one example of how you can solve these. It's not, I don't have like many questions on the homework on doing this, but that is just an example. Okay. And so then the last thing that I want to talk about is, all these angles and things have values, right? So what we want to be able to do is to use our unit circle to be able to relate the angle value to the value of the function. Okay, so what do I mean by that? All right, so let's say that we have something like, let's say we want to look at sine, and let's pick an angle, we'll say 30 degrees. Okay, and I want to be able to answer what is that in radians. Okay, so going back to the radians, but then the value, it also has a function. Okay, so if you were to plug sine of 30 in, what would you get? Okay, that's kind of what we want to look at. And as you get familiar with the unit circle, these will become easier and easier. All right, so I'm just going to draw the portion of the unit circle that we need. So let's say that we have, so 30 degrees is somewhere about here if you look on your unit circle. All right. And that corresponds to pi over 6. Okay. So the radian value of 30 degrees is just pi over 6. Okay. However, something else that you'll notice is it has a little x and y coordinate out by it that's square root of 3 over 2 and 1/2. Okay. Well, how do I answer this function value? Okay. Well, let's look at this as a triangle. So instead of on a circle, let's look at it like a triangle. Okay. Which, as you can see, I've kind of got a triangle drawn there. Well, I know that 3 over 2 corresponds to my x and y, or my x direction, which is here. Okay. I know that 1 over 2 corresponds to my y direction, so my up and down. Well, I am looking at this angle here and this angle there in the unit circle. Well, sine corresponds to the y direction. Okay. So therefore, the function has a value of 1/2. All right. These may be a little bit uncomfortable to start out, but as you do more and more, you'll grow more and more comfortable with them and be able to reference your unit circle readily to be able to know these. I'm not going to quiz you on memorizing the unit circle or anything like that, but as we go on, you'll just become more and more comfortable. So this concludes section 4.3. If you do have any questions, please feel free to email me. And as always, have a great rest of your day.